Hey everyone, this is Dr. Walker. This is video 210. It is called Adding Electric Fields. So we're going to learn how to find the electric field at a point when there's more than one electric charge. So it's going to work just the same way as adding electric force vectors. If you have more than one electric field because you have more than one charge, you have to use vector addition to add the electric fields. Let's go ahead and do a conceptual example, and then there's going to be another video where there's a guided example where we do a numerical example. So this example says, what is the direction of the electric field at the dot? So the dot is over here. So the A, B, C, and D are just the answer choices. There are two charges that have the same magnitude. One is positive and one is negative. You know that each charge creates an electric field. So we have to add the electric fields at this point using vector addition. This one is a little bit simpler than the one that we did with electric force because the charges and the points are along a straight line. So the steps to doing this type of problem is to draw an arrow representing the electric field due to each individual charge. So we know that the electric field always points away from a positive charge. So if we cared about a point over here, we would say, okay, there's an electric field this way due to this charge. But we care about a point over here. So what I'm going to do is I'm going to redraw the charges just so that I have more room. Okay, and I'm going to call this number 1 and this number 2. So ignoring charge number 2 here, just completely ignore it. The electric field due to a positive charge always points away from that positive charge. So if you're over here, it would point to the right. If you're even further away, it still points to the right. So this is the electric field due to charge number 1 at this point over here. And now let's ignore charge number 1 and draw the electric field due to charge number 2 at this same point. The electric field always points toward a negative charge. So if we were over here, we'd say, okay, the electric field points towards the negative charge. We're over here to point to the right. So the electric field is going to point towards the negative charge. So this is going to be E2. Notice that I'm not drawing the electric field where the charge is. I'm drawing the electric field where the point is that the question is asking about. The next thing you'll notice is that I drew the arrow for E2 bigger than E1. And that's because the electric field due to a charge is calculated using the equation kq over r squared. So the smaller the distance, the bigger the field. Charge number 2 is closer to the point than charge number 1. This would be the distance r1 over here that we'd plug in here to get E1, and then this would be the distance r2 that we'd plug into here to get E2. So I didn't draw the arrows to scale, but I did draw arrow E2 bigger than arrow E1. So using vector addition, how do we add these two arrows? Think about it. Since they're just along a straight line, we can and they're going in opposite directions, we can just subtract them. So if you could even do it tip to tail if you wanted to. You have an arrow this way, and then you're going back this way a little bit. Well, you started over here and you ended up over here, so the net electric field is going to be to the left. So the answer to this question is B, and that's to find the electric field at this point. I strongly encourage you to pick other points and to find the electric field direction at those other points. So I'll leave a question for you to answer in the comments. What if we had picked a point right here in the middle, in between the two charges? Which way would be the net electric field? I hope to see your answers in the comments below.